So with this, we are going to move to a collaborative project, a project that Florida International University, University of Nevada, Reno, and University of Oklahoma are participating in that project. It's called Risk and Resilience of Bridges toward Development of Hazard-Based Assessment Framework, Research Needs and Benefits of Accelerated Construction. Dr. Islam MANTAWY from FIU, Dr. MUSHARRAF ZAMAN from OU, and Dr. MOHAMED MOUSTAFA from UNR are heading this project. We're going to pass to first Dr. MANTAWY to start and get the flow on this presentation. Dr. MANTAWY.
Thank you for the introduction. So as Dr. Marabi said, this is a collaboration between Florida International University, University of Oklahoma, and University of Nevada, Reno. We have myself, Dr. Zaman, and Dr. Mustafa as PIs at each university, and we have Dr. Edward Cooley from University of Oklahoma. He's in the area of risk. So starting with this project, we just started lately, so as other project, you'll have we will focus on the objective and background and the plans and deliverables. So first of all, we're just gonna define resiliency or resilience definition and assessment metric. Here there is tons of definition based on the agency, and here we are using the National Research Council and NIST definition, which is actually the ability to prepare, plan, absorb, recover from, and more successfully adapt to actual or potential adverse event. You can see here in the cloud image, the resilient cloud, which is include all this wording, and based on the research and literature, the bigger words are the more common in the literature. So for example, planning, understanding, community, adapt, social capital, anticipation, and so on are kind of broad in the literature. So moving forward to assessment metric here, there's a lot of assessment metrics for resiliency. What we're trying to utilize here and maybe adapt is the methodology by University at Buffalo, which is 4R methodology. First of all, you have the famous triangle, resiliency triangle. Here is a chart. The vertical axis is the functionality, and horizontal axis you have the time, and the event and the disruption will happen between time 0 and time 1. So first of all, you'll have an event. It can be an earthquake, can be a tsunami, can be flood, can be fire, or even a long-term chronic environmental event. So first of all, you have a pre-hazard functionality, and you target it, and you have, after the event, you have functionality loss, as you can see in the black arrow, and the what's called robustness, which is the residual functionality. And your target is to restore to the pre-hazard condition. This happened over time, which is called rapidity in the term of 4R methodology, which is basically the downtime between the event and the full restoration. This includes impeding factors such as having utilities in place, having crew to go and inspect, and so on, and actual repair time. The area in the shaded red, we can call it triangular for now, is what's called the resilience indicator. And here what you can see, and the repair to fully restore the capacity. So there is, in this 4R methodology, there is 4 definitions or metrics: that robustness, rapidity, redundancy, and the resourcefulness. I'm gonna go one by one, trying to broadly define each of them. So what we target here in this research is to actually expand the 4R methodology to have it like 5R methodology by adding the social aspect to it. And it's a regional social aspect because every region and area is different. So first of all, to define those 5 terminologies, the robustness, as I said, the ability of the given system to resist given hazard with minimal or no functionality loss. Rapidity is the recovery time needed for a given system to bounce back to the pre-hazard functionality level. Redundancy is the inherent component that keeps the system functionality even after the loss of part of this element. And the resourcefulness, as I mentioned, is the ability to mobilize resources to recover quickly after the hazard. And one we're trying to add here to this framework is to consider the regional societal impact, including economic, the well-being of the public, and the social impact, including safety and mobility. So the project objective is first of all, we're going to try to document the current state of practice related to assessment of risk and resilience of bridges nationally and internationally. Synthesize this state of practice and includes other structures such as building and nuclear facilities against man-made and natural hazard. The goal will be identifying existing framework that can be adapted or adopted to the bridges, and conducting target online survey or personal interviews with the DOT, cities, and counties to evaluate the current practice and efficacy of existing bridge performance tool. And the last objective is to develop kind of holistic resilience framework that can include in this framework all the hazards and include existing bridges, newly constructed ABC bridges, and also accelerate, upgrade, and repair after the events. And at the end is develop one framework, and we're gonna start with seismic because kind of there's a lot of sources and tools that we can use to develop such resilience framework. So back to the triangle here is someone can ask how this project can be relevant to ABC. So I'm just trying to explain it in terms of this triangle, resilient triangle. So this is what I showed a couple of slides ago. And if I'm asking, if we have a bridge that built 50 years ago and the type of steel or more, type of steel was like grade 40, and the action was to retrofit the bridge so that apparently upgrading the structure will increase the pre-hazard functionality, so we are better prepared to the event. So that will increase, as I mentioned, the functionality. If we assume that functionality loss is the same, we have the same drop, so you actually increase the robustness. And the area of the triangle, which is a resilient indicator, will shrink, which is a goal. So this will affect the robustness and rapidity in the resiliency framework. If we are to have accelerated repair after the event, this will happen. The rate of the repair will be steeper, so you will reduce the area, and this will make the system or the bridge back to the functionality sooner, which will enhance the resiliency as a whole. So our work plan here is to develop this framework through literature review, very extensive, and also surveys and interviews with stakeholders, including DOTs, county, cities, and so on, because the social aspect. When we develop the framework, we're targeting, for example, we have to define selected bridge location because we are focusing on this the structural resiliency and impact of the resilience of bridges. And once we define what is possible hazards, such as if you have a location where a bridge is in flood zone or in a seismic active area, so you can define which is your hazard that can be included. You can develop framework for each of them, calculate what's so-called resilience indicator for each event, and have a cumulative or aggregate resilience indicator. And if you have acceptance measure for this one. If not, you can propose to upgrade the system or be ready with accelerated repair after the event. From now, I will pass the presentation to Dr. Mustafa to talk more about the task and PI responsibility in students.
Thanks, IM. Hope everyone is doing great. Actually, as you have seen in the work plan summary that Islam just presented, we will try to present this information again, but in more details. So this is a collaborative project. Like, we have several tasks between 3 institutions. FIU is leading some of the tasks. Oklahoma is University of Oklahoma is leading some other tasks, and here at UNR I'm leading this first task at least. So we have our first task to kick off this project. I mean, some of the tasks will be running in parallel, as you'll see towards the end in the timeline. But our very first focus here is to, as most of the projects, as you have heard from the morning, many of the projects we start by a careful literature review to see what's out there, collect the information and synthesize this information. The work that we are doing here at UNR will have two actually fold objective. So we are focusing on bridges. That's true, because that's the objective of the project in general, to apply this resiliency and risk frameworks for bridges. But there is a lot of knowledge out there for other structures as well and other types of infrastructure. So the twofold objective here of this task is to learn from what people in other disciplines have done, not disciplines but other applications. Basically in the buildings world, they are much more advanced than or ahead of us in the bridge community, I mean, in terms of these type of frameworks. So if you go historically and check how the design emerged, we started by the force-based design. I'm talking about seismic, for example. We started by the force-based design several decades ago. Then displacement-based design start kicking in maybe 2-3 decades ago, and then it emerged or it upgraded itself into performance-based design. And recently you are seeing the performance-based design frameworks emerging further to resilient-based design. So if we take buildings as an example, we can see how the codes and the design guidelines emerged over the years and try to map this to the bridge world. So this is one part, or this is one area that we will focus on, how these frameworks emerged and developed for buildings. And then we will see what's the current state of practice out there for bridges. Maybe there is no formal frameworks yet, like in buildings, for example, the FEMA P58 or some of the ACE frameworks, performance-based frameworks. These are well established for buildings. We might not have something as robust for bridges, but we will see what's out there in terms of individual research studies. Recently, they asked to develop some performance-based design, guidance for bridges through an NC-SHARP project that was just completed a few months ago. So this would be our starting point in the bridge world, and so on. So that at the end of this task, we will provide the synthesis of two worlds, the bridge world and the building world. So if we can go to the next slide. The second task, and this is what University of Oklahoma is leading, Dr. ZAMAN is leading, this will focus actually on survey. We instead of looking for the literature, which we will do here at UNR, we actually would like to learn from the people and get different perspectives from bridge owners, from stakeholders, from various stakeholders. And this will be also a collaboration not only from the engineering folks, but we will have some social scientists helping with this, as well as Islam outlined earlier in the presentation. So there will be a survey first for the existing tools and current practices. And when we talk to bridge owners or some of the advisory committee members that we have here in the ABCTC, and see what's the current metrics that they use, how do they use do assessment, what do their basically interpretation of risk and resiliency. So that will be one objective of the surveys, or one type of surveys. The other type of surveys will be focusing on stakeholders, and this, as I said, will have beyond engineering. So it will be a collaboration internally at University of Oklahoma within the National Institute of Risk and Resiliency and the Civil Engineering Department there, and they will work closely with the ABCTC leadership to identify stakeholders and interview them to gain the insight for this, perception and benefits towards the ABC applications specifically. So next slide, please. The third task, and this is what Islam mentioned earlier, and he would be leading this at FIU, is to develop a holistic resilience and risk assessment framework. So we have seen earlier, a few slides ago, some of the components that will go into this framework that is being envisioned here. It will be upgraded to eventually have what we call it the modified 5R methodology, and this will be the generic or a holistic one that could later on be applied for different types of natural and man-made hazards or extreme events. In task number 4, if we can move on to the next slide, please, we will just take the same, framework that's being developed in task 3 and just, zoom in a little bit and focus more on seismic. And this will be a close collaboration between FIU and me here at UNR, since we have been doing a lot of work in earthquake engineering, performance-based design, and seismic design in general. So we will try to specialize the envisioned framework for seismic applications. So we wanted to show this as an example. How would you, this envisioned framework, how would we take one step deeper and apply it for seismic applications? So we will focus primarily on earthquake hazards and seismic hazards and see how we can adopt this framework and make it specific. And by being specific here, one part or one component of this envisioned framework has to do with the hazard itself. So when we define hazard in a generic way as a part of the holistic framework, this might not go into details of how each hazard is being, defined for assessment purposes. When we focus in task 4 on the seismic, we will provide some examples, clear, specific examples, the seismic hazard is a whole research area by itself. It's a very mature area. We will see how to, use some of these emerging, like Stanford, for example, they have done a lot of work in the seismic risk assessment frameworks, and with focus on the seismic hazard, how to define earthquakes, how to, from a statistical perspective, from a probabilistic perspective, not only to develop seismic hazard curves and statistical functions, but also take it one step further and see in the terms of the assessment, what are the seismic fragility that are associated with that, how to apply them for different components of the bridge, ABC specifically. We'll see if there is fragilities developed for ABC connections, for example, take it one step up and go to the full system level and have fragilities for seismic fragilities for entire bridges and ABC systems. So that's what we mean here by going from the holistic framework that we will develop in task 3 to make it more specific in task 4 for a seismic application. So what we will show in task 4, everything that will be seismic, fragilities later on could be replaced with hurricane fragilities, for example, or flood fragilities, where you can apply it as part of the holistic framework. So we can, next slide, please. And the last task, which we will all be sharing, of course, is the deliverables and, wrapping up the project. So we'll be providing several documents, the ABC guide, which is the typical, output from the ABC ETC projects, a final report, of course, that summarize, all these things. And we will try to specifically promote ABC to stakeholders as part of this initiative. We can package the resilience-based, the resiliency and risk assessment framework, specifically promote it for ABC application to see if we can have further benefits. Of course, the results will be general enough that could benefit ordinary or general or bridges, but we will try to see what are the unique aspects of ABC benefits so that we can promote ABC in an indirect way. Some of the tasks that we have already been working on is the literature, as I said, and these are just some examples. There is no need to go down the list, but we have been looking at here at UNR and FIU and the University of Oklahoma. Each university started looking at the different components of literature and different pieces, and these are samples of the work that we have reviewed so far. And the last slide is the timeline. So we are a little bit late here, so this is an ambitious, timeline. We will try to stick to it, of course, but at least, here at UNR, the first task, we couldn't, start until only last month. And even the students, I'm doing most of the work myself yet. I'm waiting for one of the new students to join us either in the summer or early in the fall to wrap up this project. So we are going to stick to this timeline as much as we can, but at least some of the tasks will be running in parallel. So we know for sure that if one university like here at UNR, I don't have the student yet, for example, I don't have all the progress that I am wishing for yet. Other universities are picking up some of the progress. So at the end of the day, we are expecting to wrap this project up by the mid of next year. And in summer 2020, we'll have 2022, I mean, we'll have the deliverables as promised. So that's what we had to share with you today, and we will happy to take questions. And thanks, everyone.
Thank you, Dr. Mustafa. Thank you, Dr. MANTAWY.